This session on leak detection is part of the JICA training course, Small-Scale Water Purification by EPS and Management Techniques in Water Supply Services. I'm Uezato from Facility Division of the Nambu Water Supply Authority. Later in this video. Now, let us begin. First, let me briefly introduce the Nambu Water Supply Authority. We are in charge of water supply business in two towns, namely Haebaru and Yaese towns located in southern region of Okinawa main island. We have 21 staff members. As of March 2020, our supply population was 71,386, number of households supplied was 20,664, service area was 37.72 square kilometers, annual water supply was 7,689,000 cubic meters, and average daily water supply was 21,008 cubic meters. Next, let me explain our water supply system. We supply potable water to our customers by dividing our pipe network into three systems: Arakawa Branch System and Tsukazan Service Reservoir System, in which we distribute purified water received from Okinawa Prefectural Enterprise Bureau, or OPEB, and the Yaese Service Reservoir System, where we supply a blend of water from OPEB and water from our own Mabuni Purification Plant. The blending ratio at the Yaese Service Reservoir System is 25% from our Mabuni Purification Plant and 75% from OPEB. This is our Mabuni Water Purification Plant. It has daily treating capacity of 2,500 cubic meters. Its source water is groundwater. The water goes through slow sand filtration and disinfection, then transmitted to Yaese Service Reservoir for distribution to our customers. We have been cooperating with JICA training programs since 2010 and have mainly provided sessions on leak detection for participants from various parts of the Pacific Island countries. This is a photo from a JICA training back in 2013. And this photo was taken in 2015 at a session on leak detection held as part of the capacity enhancement project for Samoa Water Authority in cooperation with Okinawa. Let me move on the introduction of equipment that we use for leak detection. This one is called listening stick. It is used to listen to leak noise with your ears by placing the tip of the rod on meters and valves. Next one is leak detector. By placing the sensor or pickup on ground surface or pipe accessories, you can convert leak noise into electric signals and amplify it to listen with headphones. The detector set consists of an amplifier, a handset with sensor, and headphones. Next one is metal pipe locator. By applying the principle of electromagnetic induction, it identifies the depth, direction, and location of buried metal pipe from ground surface. The locator consists of transmitter and receiver. This is metal locator. It locates buried fire hydrants, valves, and manholes by sending electromagnetic signals and detecting magnetic field produced around metal objects. Lastly, let me introduce water pressure recorder. It is installed on fire hydrants within a distribution block to keep track of water pressure. We then utilize the obtained data for pressure management. The equipment consists of main unit, pressure sensor, and coupling. From here, let me explain how we conduct leak detection. We manage our service area by dividing it into 78 water distribution blocks. Those distribution blocks were established for speedy leak detection work. Officers in charge analyze parameters such as flow rate and identify blocks with apparent leak incidents for detection work. This color-coded map shows the 78 water distribution blocks. Our leak detection survey consists of leak detection for individual domestic meters with listening sticks and leak detection on road surface with leak detector. Here is the flowchart that shows our standard operating procedure. It is available on Google Classroom. Let me explain further with a video clip on how to use listening stick and leak detector. Now, let me explain how to conduct acoustic leak detection for individual domestic meters. Using a listening stick, domestic meters installed within the distribution block are surveyed one by one. If you hear leak noise, check the leak indicator to see if it is moving. If the leak indicator is moving, stop water supply with the stop valve. Check with the listening stick once again. If you still hear a leak noise, there is a leak, so we conduct repair work. When you use a listening stick, please keep in mind the following. First, don't grab or touch the bar part of the stick, because that would hinder sound transfer. Second, don't touch any irrelevant objects, such as the frame of the meter box, with the bar. It will generate distracting noise and make it difficult to hear leak noise. Next, let me explain how to conduct acoustic leak detection on road surface. First, using metal pipe locator, path of buried pipeline is located. Then, leak detection survey is conducted along the identified path with leak detector. This is the first step. We search for a buried pipe with metal pipe locator. The distance between the transmitter and the receiver should be around 5 to 10 meters. When we locate a pipeline path, we mark it with spray paint. Metal pipe locator reacts to ductile iron pipe and steel pipe and locates them. To locate HIVP or shock-resistant hard PVC pipe, the locator reacts to outer sheet, or which is detectable underground warning tape, laid over the pipe at the time of pipe installation. Now we move on to step 2. Leak detection along the identified path. To set up leak detector, hang the amplifier around your neck and connect the handset and headphones.
とヘッドホンを接続します。
Turn it on and wear the headphones. Now it's ready to be used.
ヘッドホンを耳に当てて、これで導水探知機のセットが完了しましたというか。
With the leak detector, we conduct leak survey at about 1 meter interval along the marked pipeline path. When leak noise is heard, we mark the location with spray paint and conduct repair work. Please be careful of vehicles and pedestrians when you conduct a survey, as you will be wearing sealed headphones and may not hear them. This is the correct way of using the handset. And this is the wrong way. Again, this is the correct way. And this is the wrong way. The latter case was wrong because you can hurt your ears with the loud noise the pickup sensor makes when it hits the ground. Please make sure to keep the trigger switch or listen button at off state until good contact is made between pickup sensor and the ground. This concludes my leak survey demonstration. I'm Tomonori Jahana from NAMP Water Supply Authority. I hope you found it useful. Now, you'll hear 4 sound recordings. Please guess which one is leak noise from service saddle mounted on VP pipe or PVCU pipe. Number 1. Number 2. Number 3. Number 4. The answer is number 2. Number 1 was the sound of wastewater flowing through sewage pipe. Number 3 was the sound of a vending machine. And number 4 was the sound from a transformer mounted on a power pole. What we introduced on this video is a basic leak detection method. Please use it as a reference to compare with other detection methods in your country and come up with various ways of application that suit best. With that, let us close this session. We wish you the best luck in your future endeavors. Thank you for watching.